Welcome to the first tutorial for our Poly packet. So there are going to be some rules about polys or polynomials, as they're really known by. And the first rule is this: you can only combine, that combine means add or subtract, like terms. And we know that when we solved equations, right, when there were like terms on the same side of the equal sign, we were allowed to combine them, but we couldn't combine things that weren't alike. So we're used to this rule. So just as a reminder, like terms are numbers, whether they're positive integers like 4 or a negative integer like -3, or whether they're a fraction like 1/2. Those we can all combine. Other like terms would be any term that has an x in it. So 5x, -2x, x, even x over 5. Those are all like terms, and they can be combined. They can be either added or subtracted. So just as a reminder, obviously, -3 plus 4 is equal to 1. We could put those together. And -2x plus 5x is 3x. So it would make sense then that if rule number 1 is that you can only combine, add or subtract, like terms, then rule number 2 is just the reverse of that, just to remind you. You cannot combine unlike terms. You need to be reminded of this because sometimes people forget. 2x plus 3 is not 5x. That's like saying 2 pianos plus 3 equals 5 pianos. No, that's crazy. But you can combine, and you cannot combine 4x plus 8x plus 9. You can, however, combine 4x plus 8x because those are like terms, so those equal 12x, but you can't bring 9 in with it. 9 stands alone. All right, so when we're looking at example 3, we notice that we can combine like terms. So here we've got 5x plus 6x, and that gives us 11x. And then we notice that we've got 7 plus 1, and that gives us 8. So what we're doing so far is combining like terms. Rule number 3, you can add and subtract polynomials by combining the terms that are alike. So polynomials, poly meaning many, right? Many termed thing. So a polynomial, that didn't sound very technical, but polynomial, we can have a polynomial like 2x. That's a monomial. Or we could have a polynomial like 3x minus 1. That's a binomial because it has 2 terms. We could have a polynomial like this, 4x squared minus 5x plus 7. That's a trinomial because it's a polynomial with 3 terms. So we've seen polynomials, we've worked with polynomials. Just a reminder of the term polynomial. So let's say we were given the polynomial 3x plus 4, which is of course a binomial because it has 2 parts. So we were given 3x plus 4 plus 2x plus 6. The parentheses make it look all official, but it's really the same problem as the one we just did in example 3, right? We're just going to combine the like terms that we can. And so the red arrows indicate the fact that 3x and 2x are like terms, so we can combine them. How many x's do we have if we have 3 x's and then another 2 x's? Well, we have 5 of those x's. How much do we have if we have the number 4 plus number 6? Well, that's the number 10. All right, so we're going to add polynomials. And one way to add them is to consider bouncing off the sign. You don't have to do this bouncing, but if you want to, this is what it looks like. You would say, okay, I'm going to start with 3x. I'm going to bounce off saying 3x plus, Who am I going to add 3x to? I'm going to add 3x to 6x because that's its like term. 3x plus 6x is 9x. And then I'm going to take 7 and say 7 plus 5 is 12. You don't necessarily have to bounce off, but that just reminds you of what we're doing. So we'll continue. 5x plus 4x, that's going to give me 9x. Negative 3 plus 1, if I put that in my calculator, I get a negative 2. 8x plus negative 6x, if I put 8 plus a negative 6, or if I put 8 minus 6 in my calculator, I get a 2x. 7 plus 8 is equal to 15, so I have a positive 15, right? You have to be really careful. I know 7 plus 8 is 15, but if I just wrote 15 like that, isn't that kind of weird looking? 2x 15. Because 15 is positive, I have to put its sign to the left of it. So 2x plus 15. So note, all I'm doing right now is combining the like terms. So I see the like term of 9x and 6x, and I'm just combining them. 9x plus 6x is 15x. And then I see the like terms of 7 and a negative 2, and I'm combining those. 7 plus negative 2 or 7 minus 2, both of those will give you, if either one you use, put it in your calculator, it's going to give you a 5. So what we've been doing so far is adding polynomials together, actually adding binomials together, and doing that, we're adding like terms. Or, sorry, we're combining like terms. Sometimes we're subtracting. So now we see instead of binomials that we're going to add, we have polynomials that have 3 terms, and that is our trinomial. I'm just saying these words. You're not going to be tested over them, but it's nice to know what you're dealing with. So we've got you're not going to be tested over the vocab. Obviously, you're going to be tested for what we're doing, but not the vocab words. So here we go. I see that I have a 5x squared. I see I have a 2x squared. If I'm adding them together, I end up with a 7x squared. So we're doing the same thing, but now we have 3 terms for each polynomial. If I have an 8x and a 4x, then 8x plus 4x is 12x. If I have a negative 12 and a positive 5, then negative 12 plus 5 is negative 7. Same thing, I've got a 3x squared here and an x squared here. And this always gets tricky. Sometimes students just want to say 3x squared plus x squared is just 3x squared. But that wouldn't be right, right? If we have 3 cookies plus another cookie, we've got 4 cookies. So if we have 3x squareds plus another x squared, that means we have 4x squareds. And I'm looking at the negative 10x and the positive 5x. We have negative 10x plus a 5x, which gives us negative 5x. And our last term that we're looking at is a 4 and a minus 1. 4 plus negative 1 is going to give me a 3. I also could have put in my calculator 4 minus 1, or put in my head 4 minus 1. And so it's important to know that we can apply what we just did to something like this. We've got a, let's say, 1, 2, 3, 4, 5, a 5-sided figure, and we are going to see what the perimeter is. And so to find the perimeter, we're going to add the sides together, right? If we were going to find the area, we would be doing multiplying, though this would be a little bit, we'd have to break this up into triangles if we were going to do this, an area for this. But perimeter means add the sides, so that's just a reminder. Okay, so here we go. It says write an expression to model. So our expression, our writing an expression means this. I'm going to start with 4x minus 1. I'm just going to say 4x minus 1 represents one side, plus, and I'm going to add the next side, 3x minus 4, plus, and I'm going to write the next side, 6x minus 3, plus, the next side plus the last side. So this is just a long line, a long list of like terms. We have like terms that have an x as part of their terms, and then we have like terms that are just numbers. Let's combine the terms that have an x. So we'll have 4x plus 3x. Let's see, let's keep track. That'll be 7x plus a 6x. It's going to be 13x plus another x, 14x, 15, 16x. All right, so we have 16x there. And then, let's see, let's look at the numbers. We've got a -1 and a -4, that's a -5. And then we've got a -3, so that's going to be a -8, plus 12, that brings me to a 4. 4 plus 7 is 11. Now, you didn't need to do it in your head like that. You could have just put all of those numbers in your calculator. You could have put -1 minus 4, or -1 plus -4, either way, same thing, -3 plus 12 plus 7, hit enter, and you should get 11. Okay, sometimes adding gets crazy. And it's good to know that not everything is perfectly ordered because that's not the way the world is either, right? So we can deal with it. We can make sense of it. So what looks different about these two polynomials? Well, first of all, I see that I have a 5x squared here, and I have a -3x squared here, but surprisingly, I've got this extra term here. I don't have an x cubed term here. Now, for some people, that's no big deal. For other people, that really bothers them. So one thing you could do is this. Since I don't have an x cubed term in this first polynomial, I could write 0x cubed. You okay with that? We can do that. Then I can rewrite everything else in this polynomial, and then it helps when I'm trying to combine like terms. Now that's just to help you to understand. If you don't need to do that, you don't have to do that. Whoops, I was just about to write a +8. It's dangerous to write and talk at the same time. All right, so here we go. I rewrote it. I'm going to use it because I'm looking at the 0x to the third plus a -6x to the third. And if I put 0 plus -6 or 0 minus 6, I'm going to get the same answer. I'm going to get -6x cubed. Then I'm going to look at the 5x squared plus -3x squared, and that's going to give me a positive 2x squared. Then I'm going to look at the -2x plus the 7x, and that's going to give me a positive 5x. And then the very last one, we've got a -4 minus an 8. So -4 plus -8, same thing, is a -12. So we had to do one little adjustment to make this problem look like the other problems that we've been doing. Let's look at number 5. What's the problem here? The way I see it is everything's good. We've got an x squared and an x squared. We've got, oh man, we don't have an x term in our first polynomial. So once again, you don't need to do this, but for a lot of people, it helps them to get this type of problem right. If I see that I'm missing a term that would match up with the second polynomial, I can do just what I did in the problem above. I can say, well, I don't have an x term, so I'm going to put a 0x. That means I have 0 x's, which is true. It's just kind of stating the obvious. When I rewrite it like this, it just helps me to understand what to do next. Because now I've got a term that matches up with each term. So 3x squared plus 4x squared, well, that's 7x squared. 0x plus -8x, that's -8x. And then we've got -9 plus a 5, which is a -4. If you know a shortcut to getting that same answer, more power to you. You don't have to do what I just did. Once again, that's a really good way, though, to make sure you don't make any mistakes. I believe that's it, and that is. All right, you made it through your first Polly Packet tutorial. Go, go, go. Get through this packet and see if you can even challenge yourself and test early and earn a free day or two. All right, see you at the next tutorial.